Hi everybody, I'm here with another tutorial and this one's in AutoCAD Civil 3D. I'm going to show you how to make use of 3D point data, specifically data which has been taken in the vertical plane. In this case I'm using measurements of the front of an existing row of houses that I took using a Leica theodolite. Civil 3D seems to automatically default to the horizontal plane for the workspace when you go into it, which is fine if you're using data for a 2D drawing, but not so useful for the 3D modelling. So there's a few steps that you can take to adapt the point data to go into the vertical plane if you need it to. So let's get started. Okay, so you want to start by inserting your survey data. So go up to the insert ribbon and click on import survey data, and this will bring up this box. This is where you create a database for that data you've got, and you can set in certain parameters that relate to that particular survey. So here I've created one called Georgian Houses Second Survey. Once you click next, you'll then get taken to this next dialog box, which has some options at the top of what data type you want to insert. Go and select the data format that you have. Mine is a point file. Then click on the small green cross on the right side of the dialog box. This will bring up the file selection window and you can choose your file. Mine is a .out file, which is effectively a notepad file with my measurements listed in the columns. So point number, easting, northing and Z for the height from the ground. So just a quick note about these file types. The final file type I received after reducing my data was a .out file, which had the exact coordinates and heights in it. I'd started with the raw data from the survey, which looks something like this. Each column represents a different measurement, with the first being the point label, but really it's unusable for one main reason, and that is that the data is relative to the instrument. Therefore, should another survey data set be put into the model with this one, the points would not coincide correctly, therefore reducing the accuracy of the model. This would not have been so much of a problem if you're only using one set of data, but in my case I had 3 or 4 surveys which I needed to combine together, so I needed it to be right. To make sure my points are all right, I used a DOS program, which I'm unable to use on Windows 10, so I can't actually show you, but this is the intermediate stage. After I processed this, it resulted in a space delimited file with points, easting, northing and Z, as you can see. And it's called space delimited because there are spaces separating the values. If there were commas separating the values, it would then be comma delimited. So now we've selected the correct file, we'll then need to specify the right file format, which is down here in this box. And then you can check in the view window that you've got the right one. So your data should be in the columns where it needs to be. I can see here that all the points and point numbers are in the right column, so I'm good to go. I don't do anything with the networks page, as it's more in depth than I need, so I'll skip this one and go straight to the final page of the dialog box. I leave all of these the same except for one vital checkbox at the bottom, which is the import survey points box. If this isn't checked, your points don't go into the file, and it's just the database which is set up. If you want to change some other parameters, feel free, fiddle around and see what works for you. Once you're done, click finish and we're off. As the points are all in a vertical plane, they're all sitting on top of one another and are not very easy to distinguish, apart from this one anomalous point which I'm just going to delete. The first thing to do would be to look at them from the correct viewing angle, but unfortunately, as you can see, they disappear when you go into model space, so this is about as helpful as a chocolate teapot. To sort this out, the first thing to do is select all the points and change the label style in the properties pane by just typing in properties. This gets rid of any information that we don't need and leaves me with just the label number, which makes things a little easier to understand. Of course, there's different information if there's different information that you require, then you can have a play around and fit the right option for your application. I've used this particular numbering system to allow me to know where the points are on the facade as well as the survey number that it is. So 206 relates to the 6th point on the second survey, for example. And this picture shows you where all the points are on the facade. once you click the settings tab, you want to be going to point styles. So if it's as it's just been inserted, it's going to be basic, and you can tell what type of point styles you've got in your drawing, because they'll have a little yellow arrow next to them, the ones that are included in the drawing. So if you start with basic and you find that it's not doing anything to your points, and try another one that's got one of the yellow arrows. Right click on it and edit, and there you can edit the name, you can edit the marker style, all the different styles. I've gone for a point just because it's easier for me when I'm utilising it with photos. And you can also change it for the drawing scale, so as you're zooming in and out, the size of the marker will change, so it is always one size. You can also change the orientation of the marker, so that when you rotate the view, the marker will rotate with you. This is not really relevant when using a point, but it can be very useful when using some of the other marker styles. So here in 3D geometry, I have selected exaggerate points by scale factor in point display mode, and again I found that this is good for when you're kind of zooming in and out. It's good as you don't need to keep adjusting the text size as you're zooming in and out, for example. The next tab that will need some adjustments is the display tab. When you open the tab, the view direction drop down is plan, and you can see some of the options that determine how the points look when you're in the plan view. You can change the colour, the layer, the line type, for example, but most crucial for this application is the light bulbs in the visible column. And you can see here that in this column the light bulbs are both yellow, and that means that the points and the labels are both visible in the plan view. If you go back up to the drop down menu and select model, you'll notice that these light bulbs are now blue. If you click these on and turn them yellow and click apply, you'll now see that when we rotate the view, the points and labels are now visible. The next step is to adjust the labels to make them easier to distinguish, because in relative terms they are massive. So you want to go back to the tool space and now click the label style tab. Right click on the point label style only, and in the general tab we want to change the orientation reference from object to view. This means that they will change direction as we change view, therefore enabling us to get them into the right position for where we need them to be later. On the layout tab, I'll make a few changes, such as changing the attachment and the text size, and this comes down to personal requirements. You can play with these settings to get what you need. Once you've changed all the settings you want to, you click OK, and you'll see that now, as we're rotating the views, the text is rotating as well. However, when I look at it as a vertical plane, the labels are still in the horizontal plane, so we've still got a little bit of work to do. Firstly, I need to make sure the labels are in the right position. In this case, I know that the 206 label needs to be on the left-hand side of the model, so I'll rotate it round in plan view until I get that. And over here I can see another anomalous point, so I'm just going to delete that. I know that it's anomalous because it's not in the same area as the other points, and in all reality it doesn't particularly matter, this one point not being there, so we'll discount that and we can carry on working. Once I've got it the right way round, I need to go up to the top and change the workspace from Civil 3D to Drafting and Annotation. This will take me into the standard AutoCAD workspace, and I'm going to use some of the tools in this workspace to explode each point, which then fixes it into this viewing plane. This might seem counterintuitive as I've spent so much time getting the point labels to move, but this was so they could be in exactly the right position, and I now need them to stay there. I can't just change the settings that we were using before, because the points will revert back to the orientation that they were in when I imported them, so it wouldn't really work. To explode the points, which will effectively split them from their label and stop them from being points and turn them into objects, you need to click the explode button, which is in the modify section of the ribbon. You then click the point twice, first to stop it from being a block, Second is to separate it from the point. Depending on your point style and application, you may wish to only click this once, but have a play around with it and see what works best for you. And if I rotate the view, you can now see that the 206 point is staying where we want it to be, even though the rest are moving. The final step is to rotate the point so that it's in the vertical plane. So to do this, I will change the workspace again to 3D modelling. And this allows me to rotate the point using 3D rotate in the modify panel. Once that's selected, make sure you have auto snap turned on, meaning that the rotation will automatically snap at each 90 degrees. You can do this by clicking the little right angled symbol at the bottom so it's blue, or pressing F8. Then just select your point and rotate it. And there you go. The point and point number are now visible in the vertical plane. The only annoying thing about this is the fact that each one has to be done separately, as the centre of rotation is specific to each point and in its individual location. So I'm just going to speed through the other points so you can get an idea. So there you have it. The points are all in the vertical plane and can now be used to create a 3D model. Or, as I did in this particular case, produce a PDF that when used with my photographs in Photoshop, I was able to get a proportional image to be used as a texture map in 3ds Max. This resulted in a model which was the correct scale and I was able to take measurements from. So there you go. Thanks for watching and I'll see you again soon.